Infinity Labs, an open education initiative. Welcome back to our video series on solid programming principles. In this video, we'll be focusing on the interface segregation principle, which is an important concept in object-oriented programming. We'll be discussing what the interface segregation principle is, the benefits of using it, and how to apply it in your code. By the end of this video, you'll have a good understanding of how the interface segregation principle can make your code more flexible and easier to maintain. Interface segregation.
In simpler terms, the ISP suggests that it is better to have multiple specific interfaces rather than a single general-purpose interface. By doing so, you avoid imposing unnecessary dependencies on clients and allow them to depend only on the interfaces that are relevant to their needs. The interface segregation principle is important for several reasons. It helps to minimize the dependencies between components or modules, which leads to loosely coupled code. This allows for easier maintenance, modification, and testing of individual components. By segregating interfaces into smaller, focused units, you promote modular design. Each component can be developed, updated, or replaced independently without affecting unrelated parts of the system. With smaller, more specific interfaces, it becomes easier to reuse code across different projects or scenarios. Components that adhere to the principle are less likely to have unnecessary dependencies, making them more versatile. It encourages explicit and precise contracts between components. Clients can rely on interfaces that contain only the methods they require, leading to better understanding and more reliable communication between different parts of the system. When interfaces are segregated based on specific needs, it becomes easier to extend or scale the system. Adding new functionality or integrating new components becomes less challenging, as each interface remains focused on a specific set of responsibilities. To apply the interface segregation principle in practice, you should follow these guidelines. Understand the needs of the clients or components that will be using the interfaces. Identify the different responsibilities and operations they require. Create smaller interfaces that focus on a specific set of responsibilities. Avoid bloating interfaces with unrelated methods that would impose unnecessary dependencies. Only implement the interfaces that are relevant to each client or component. This ensures that they are not forced to depend on methods they do not use.
Let's dive into a code example to better understand the interface segregation principle.
In this example, we have the shape interface that defines a single method area. Both the circle and rectangle classes implement the shape interface and provide their respective implementations for the area method. The client class depends on the shape interface, not on the specific classes like circle or rectangle. It has a print area method that takes an object of any class that implements the shape interface and prints its area. By segregating the shape interface with only the area method, we ensure that the client class is not forced to depend on unnecessary methods like getRadius or getWidth. It can work with any shape that provides the area method, promoting flexibility and adhering to the interface segregation principle. The example demonstrates how different shapes can implement the shape interface, and the client class can utilize the area method without being aware of the specific shape details. This allows for easy extensibility, as new shapes can be added by implementing the shape interface without impacting existing code that depends on the interface.